Hello students, in this video we will discuss decision trees of module 4. What is a decision tree? Decision tree is a tree-like structure which is used to make classification rules. How I can form this classification rule? By traversing along the branches of the decision tree, I can form this decision rules or classification rules. And this decision tree is a supervised learning algorithm. That is, it follows the supervised learning technique. Every object in your dataset will be assigned to one of the predefined classes. It will be a labeled data. And here, in a decision tree, each leaf node, it represents the label. It gives you the label, or I can say it represents the outcome. And how to form this decision tree? Decision tree can be formed using this ID3 algorithm. The full form of this ID3 algorithm is iterative dichotomizer tree algorithm, which is invented by Rose Greenland, and it is used to generate decision tree from a data set. And this is used in machine learning and natural language processing domains. And it follows the greedy approach by selecting the attributes that yields the maximum information gain or minimum entropy. And what are the steps in this ID3 algorithm? We are going to make a decision tree. So it should have a root node. So first I have to create a root node. How to choose this root node? You calculate the entropy for all the attributes and then find the average information and then calculate the information gain. So whichever attribute is having the highest information gain, that will be selected as the root node. So my first step is calculate the entropy for the complete data set. Then for each attribute, calculate the entropy for its categorical values. Then calculate average information entropy and then calculate the information gain. Information gain is the difference between this entropy calculated for this complete data set minus this average information entropy. Then compare the information gain for all the attributes. Whichever attribute is having the highest information gain will be selected as the root node. This is my first iteration. And these are the formulas for calculating entropy, average information, and information gain. And what is entropy? Entropy is a measure of the amount of uncertainty or randomness in the data set. Amount of randomness or uncertainty in the data set. And this is the formula for calculating this entropy. Minus p by p plus n log 2 of p by p plus n minus n by p plus n log 2 of n by p plus n. This p stands for positive samples and n stands for negative samples. So this is a formula to calculate the entropy, then calculate average information. And you see this average information for every attribute you have to calculate. So I stands for information of average information of an attribute, which is equal to summation of pi plus ni. This I stands for the categorical values. Every attribute, it will have some categorical values. So this average information, it should be the summation of the entropy is calculated for its categorical values. So when you do the sum, you'll understand it better. Then you calculate the information gain. How to calculate the information gain? The entropy calculator for the data set minus this average information for an attribute. That will give you the information gain. So this is your data set. So for this data set, we are going to construct a decision tree. So this data set, if you look into this data set, it has 4 attributes: outlook, temperature, humidity, and wind. 4 attributes, and the 5th one is the class label, play tennis. And if you see this class label, we are having totally 14 instances. You can see this. We are having 14 instances. Out of this 14 instances, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are positive samples and 5 are negative samples. So you calculate the entropy of the complete data set. My first aim is I have to find the root node. So to calculate the root node, first step is calculate the entropy for the complete data set. Hope you remember the formula for entropy. It is entropy is equal to minus P by P plus N. P is positive sample. So how many S were there? 9. So 9 by, so 9 plus 5, it is 14. So minus 9 by 14. Here it should be minus 5 by 14. You can check here, minus 9 by 14 into log 2 of 9 by 14 minus 5 by 14 into log 2 of 5 by 14. So you be careful, it is log 2, not log to the base 10. And you calculate the entropy for the complete data set, which you got as 0.94. Next, you take the first attribute. First attribute is outlook. So what are the steps? First, you calculate the entropy for the data set. Then you take the attribute. Then calculate the entropy for its categorical values. For every categorical values, you have to calculate the entropy. Then you have to calculate average information, then information A. Now, in this data set, my first attribute is outlook. Now, I'm going to calculate the entropy for the categorical values of output attribute, outlook attribute, right? So here you check this outlook attribute, how many values are there, how many categorical values are there? Sunny, overcast, rain. Only 3 categorical values are there: sunny, overcast, and rain. So you can check here, categorical values are sunny, overcast, and rain. Now for the first categorical values, I am going to calculate the entropy. First categorical value is sunny. Now calculate the entropy for sunny. So here you check how many sunny are there: 1, 2, 3, 4, and 5. 5 sunny categorical values are there, and in that 5, how many are positive, how many are negative? I am going to do that because I am going to calculate the entropy for this categorical values. So first is sunny, no, negative sample. Second, sunny, no, negative sample. Third, no, negative sample. Fourth, yes, positive sample. Fifth, yes, positive sample. So out of 5, 3 are negative and 2 are positive sample. Now you apply the formula. So you remember the formula for entropy, it is minus P by P plus N. So totally 5 sunny were there. Out of that 5, 2 are positive. So it should be minus 2 by 5 into log 2 of 2 by 5 minus N by P plus N. So it is minus 3 by 5 into log 2 of 3 by 5. So you calculate it, you'll get the value as 0.971. Similarly, you have to do for rain. So how many rain are there? 1, 2, 3, 4, and 5. So 5 rain categorical values are there. Now I have to calculate the entropy of rain. So you have to find out how many positive rain and how many negative rain. So rain, yes, positive. Rain, yes, positive. Rain, no, negative. Rain, yes, positive. 3 positive. And rain, no. So 3 positive, 2 negative. 3 positive and 2 negative. Right? So it should be minus 3 by 5 log 2 of 3 by 5 minus 2 by 5 into log 2 of 2 by 5. Calculate the value, you will get as 0.971. Next categorical value is overcast. 1, 2, 3, 4. 4 overcast are there. And check whether how many out of this 4, how many are positive overcast and how many are negative overcast. So check the class label. Overcast, yes. Overcast, yes. Second, yes. Overcast, third, yes. Overcast, fourth, yes. So it is 4 categorical values of overcast are there and all 4 are positive, no negative. So it should be minus 4 by 4 into log 2 of 4 by 4 minus, Since there are no negative samples, you will get the value as 0. Now what is the next step? We have calculated the entropy for all the categorical values. You can check here. We have calculated the entropy for all the categorical values. Now I have to calculate the average information. So what is the formula to calculate the average information? Average information for an attribute is equal to summation of pi plus ni. So this I stands for this categorical values, right? Summation of all these categorical values. So it should be, and you check this formula, pi plus ni, that is for the first categorical values, positive and negative samples total by p plus n. This p plus n belongs to this p plus n, right? What is this? Positive and negative samples in the complete data set. Complete data set. So this p plus n is the positive and negative samples in the complete data set. This pi plus ni is the positive and negative samples of the first categorical value, right? So it should be, say, first categorical value is Sunny. Sunny has how many positive and negative? 2 positive and 3 negative. So totally it is 5. So directly you can look into this denominator. So it should be 5 by how many positive and negative samples in my total data set, complete data set? It is 9 positive and 5 negative. So 9 plus 5, it is 14. Right, so 40 into this 0.971 plus it is the summation of all the categorical values, right? So here we have 3 categorical values. So you make a summation, right? Plus next 5 by 14 into 0.971 plus this, check the denominator, 4 by 14 into 0. Calculate the average entropy information for the attribute outlook. You will get as 0.693. Then you calculate the information gain, which is equal to the entropy which I have calculated for the complete data set, 0.94 minus 0.693, which is equal to 0.247. So this is the information gain what I got for this outlook attribute. Similarly, you have to calculate for temperature. Next attribute is humidity and next one is wind. For all these 4 attributes, we have to calculate. So what am I doing now? I want to find the root node. How to calculate the root node? How to pick the root node? Whichever attribute is having the highest information gain, that will be my root node. So I am calculating the information gain for all the attributes. Now come to this data set. Have a look at this temperature. What are the categorical values? Hot, mild and cool are the categorical values. So 3 categorical values. So hot, mild and cool are the categorical values. Now what I have to do? For every categorical value, I have to calculate the entropy. Right, so first categorical value is hot. For hot, you calculate the entropy. Mild, you calculate the entropy. And cool, you calculate the entropy. After calculating the entropy for these categorical values, you have to find the average information, average entropy information. So what is this? It is the summation of all the categorical values into this entropy what you have calculated for individual categorical values. So again, the same procedure. I'll explain for only one categorical value. I'll explain for hot. So how many hot are there? 1, 2, 3. Yeah, here 4. Right. Out of this 4, how many positive hot and how many negative hot? Hot, this is negative. Hot, negative. Hot, positive and hot, positive. So totally 4 hot are there. In that 2 are positive and 2 are negative. 2 are positive and 2 are negative. right? So totally 4, you can check. We are applying entropy formula here. You know the formula for entropy. It is minus P by P plus N log 2 of P by P plus N minus N by P plus N into log 2 of N by P plus N. Right? So 2 by 4 into log 2 of 2 by 4 minus 2 by 4 into log 2 of 2 by 4, which is equal to 1. Similarly, you have to calculate for cool and mild. After calculating this, what you have to do, what is the formula for average information for an attribute? It is summation of Pi plus Ni. You know this I stands for the categorical values divided by P plus N. P plus N is the total number of positive and negative samples in your data set. Now we are considering the complete data set. So P plus N will be 9 plus 5, which is equal to 15. Sorry, 9 plus 5, which is equal to 14. Right, so it should be 4 by 14. This 4 by 14 into 1 plus next is here denominator 6 by 14 into 0.9179 plus then this 4 by 14 into 0.811. Right, you calculate the average entropy information. Then you calculate information gain, which is the difference between the total entropy, which is 0.94 minus this one, 0.9108, which is equal to 0.0292. 0.0292. Similarly, you have to calculate the information gain for the attribute humidity and for wind. Now here I have written the information gain for all the attributes. 0.247 for outlook, 0.0292 for temperature, 0.153 for humidity, and 0.048 for wind. Now calculate all, see this, pick the highest information gain. Which is the highest information gain? 0.247. This 0.247 belongs to which attribute? The first one, outlook. Right? So outlook will be my root node. You can start your decision tree. Outlook is your root node. Now you know this outlook attribute has how many categorical values? Sunny, overcast and rain. Sunny and overcast and rain are the possible values. Right? So it should be sunny, overcast and rain. Sunny, overcast and rain. Now you check this. Check sunny. First sample is negative sample. Second also negative. And third it is negative. Fourth it is positive. And fifth also positive. So it is having few instances are negative, few instances are positive. So I cannot decide anything for this sunny at this stage. I cannot define the class label for sunny at this stage because few instances are positive and few instances are negative. Then you check the overcast. Overcast, first instance is positive, second positive, third positive and fourth positive. So you have 4 overcast instances, all 4 are positive. Right, since there are no negative samples, right, it is very clear all the overcast are positive, and in your decision tree you can mark the label for this overcast. What is the label for this overcast? It is positive. You have written yes, and this yes is a leaf node. Right, as I told in the beginning, all the leaf node will have the labels. All the leaf node will have the labels. Now the label for this overcast is yes, and this should be a leaf node and no more splitting from this leaf node. Right, no more splitting from this node. Next is you have to check your rain. Check rain. So 1, 2, 3, 4, 5. 5 rain are there, and in this first rain is positive, second positive, third is positive, fine. third is negative, fourth is positive, fifth is negative. So 5 rain instances are there. Out of this, 3 are positive and 2 are negative. So at this stage, I cannot decide the class label for rain because it has few positive and few negative instances. I cannot decide anything at this stage. Right? So now your decision tree, it will be like this. Right? Outlook is your root attribute. It has 3 categorical values: sunny, overcast and rain. Sunny, I have marked the class label. Now I have to check, for overcast I have marked the class label. Now for sunny and rain I have to proceed. Now I have to decide what could be the attribute or node at this point for sunny. So I'll start with this. So I'm taking sunny and I want to find the node or attribute at this point. So what I'll be doing, instead of taking the complete data set, I'll take a data set that has only sunny. So you have a look of this complete data set. So this sunny, how many times it is appearing? 1, 2, 3, 4, 5. Now you make a data set or a subset from this original data set that has only sunny. I'll show you. This is the data set that has only sunny. Now you have to proceed with this. Data set. Right? Now you calculate the complete entropy of sunny. So now this is my data set. In this, how many positive and negative instances? 2 positive and 3 negative instances. So how will you apply your entropy formula? It is minus P by P plus N. That is 2 by 5 into log 2 of 2 by 5 minus 3 negative instances. So 3 by 5 into log 2 of 3 by 5. You calculate, you will get the answer as 0.971. This is the complete entropy of sunny, entropy value of sunny. Next is, check here, this sunny has how many attributes? Temperature, humidity and wind. This is your class label: temperature, humidity and wind. So the first attribute is temperature. Now you check here, this temperature, how many values are there? Hot, mild and cool are there. So hot, mild and cool. Now you have to check how many hot are there. 2 hot are there. Both the hot are negative samples. So no positive. So minus 0 minus 2 by 2 into log 2 of 2 by 2, which you will get the answer as 0. Next categorical value is cool. How many cool are there? Only 1. That too, it is S. So it should be cool minus positive. So 1 by 1 into log 2 of 1 by 1 minus no negative. So it is 0, equal to 0. Next is mild. How many mild are there? 2. Out of this 2, one is positive, another one is negative. One is positive, another one is negative. So we'll calculate and get the value. It should be 1. Next is, you have to calculate the average entropy information. You have to calculate the average entropy information for temperature. So you know, hope you remember the formula. It is summation of Pi plus Ni by P plus N. This Pi and Ni this I stands for the categorical values. So how many categorical values are there? 3 categorical values. So for the first categorical value, Pi, Ni. So how many positive and how many negative? So here you can check here, no positive, only 2 negative are there. Otherwise, directly you can check the denominator. It will give you the total. So it should be 2 by, now what is your data set? Your data set is this one. So how many instances are there? 5. So it should be this denominator by 5 into 0. Similarly, 1 by 5 into 0. This denominator by this number of instances into 0 plus next is check the denominator 2 by 5 into 1. Calculate it, you will get the answer as 0.4. Now calculate the information gain, right? Entropy of Sunny. What is entropy of Sunny? 0.971. 0.971 minus 0.4 will give you the information gain. So you have to remember here, first iteration to decide the root node, I'll take the complete data set, then I'll proceed with the subsets. So how many instances are there in your subsets? That should be the denominator here. So in all the iteration, don't by mistake write 14. Don't do that. Right? Since I'm considering this as my data set at this point, this is my data set at this point, right? It should be 5. Denominator, it should be 5, not 14. You should be very careful here. Calculate the information gain. Similarly, for the next attribute, humidity and wind, you have to calculate. Check this denominator. It is this denominator 3 by 5 into 0, then 2 by 5 into 0. Right? Next is wind, humidity and wind. Now you can check the information gain for all these attributes. First is temperature 0.5, next is 0.9 for humidity and 0.02 for wind. Which is the highest one? This is the highest one. 0.9 is the highest one, which belong to the attribute humidity. Humidity when it is sunny, right? So how will you mark your decision tree? Right? Next to sunny, you will get the attribute humidity. You will get the attribute humidity. Hope I am clear. Next, you check this data set. Right? You check the data set. Humidity. Humidity is having either high or normal. You check this high. All three highs are no, negative samples, and both the normal or positive samples. Right? If you take the categorical value high, all high, it is negative. It is not a combination of positive and negative. So I got a clear cut idea. That is, when humidity is high, I am not going to play my tennis. So in marking the decision tree, humidity when it is high, you can mark the label as no. When it is normal, you can mark the label as yes. You can mark the label as yes. So this will be my decision tree at the end of second iteration. So this no, yes and yes all are your class labels. Here, next you have to proceed with your rain. So go to the main data set, pick all the rains. How many rain are there? 1, 2, 3, 4 and 5. 5 rain are there. So now only this rain should be your data set. So my data set, it will be like this. It will have only 5 instances. All 5 instances, it will belong to rain. You calculate the entropy of rain. Right. Now you check this rain has temperature, humidity and wind. And in that, sorry, this humidity, it won't come because see this decision tree, we had only 4 attributes: outlook, temperature, humidity and wind. In that, outlook is over, humidity is over. Next, you will be having only temperature and wind. Temperature and wind. So here this humidity, it won't come. Temperature and wind. Even this outlook won't come. So outlook and humidity are over. You have to check with temperature and wind alone. Right, so my first attribute is temperature, second is wind. You calculate it and find which is the highest information gain. Here 0.02 and next one is 0.971. So which is the highest one? 0.971 is the highest. Now in your decision tree, next to rain you should get wind. Why wind? Because wind 0.971 and temperature it is 0.02. 0.9 is the highest one. So next to rain, you should get only wind. Next to rain, you should get only wind. Now, if you check this, right, you check this wind. Wind has two categorical values, weak and strong. Weak and strong. So you check all the weak, yes, weak, yes, weak, yes. So it is showing when the wind is weak, I am going to play tennis. When the wind is strong, clearly it is telling I am not going to play tennis. So you can mark the splits. When the wind is weak, I am going to play tennis. When the wind is strong, I am not going to play the tennis. Right? So this is your final decision tree. You can check now all your leaf nodes have the class labels. Right? So class label is like whether you are going to play tennis or not. And this is the decision tree. It has this root node, leaf node. In between nodes, I can say as the test node, or I can say features or attributes. And how to form this rules by traversing along the branches of this decision tree. I'll form rule. So this is one rule: when sunny and if humidity is normal, I'm going to play tennis. And if it is sunny and if humidity is high, I'm not going to play tennis. Likewise, by traversing along the branches of the decision tree, I can form rules. So this is all about your decision tree. Thank you.